Hello, welcome back. Today we will discuss about PCM signaling system. So this is basically a time division multiplexing carrier system or time division carrier signaling system. So in our last lecture we discussed frequency division carrier system. So with respect to this, of course, frequency division multiplexing carrier signaling system. So where we were able to multiplex different signals and transmission was made with the help of frequency division multiplexing. With respect to this, we discussed outband signaling system as well as in-band signaling system. After a good understanding of time division multiplexing, frequency division multiplexing carrier system, let us deal with time division multiplexing carrier system, where we are inserting signals at different time slots and all those signals will be transferred over the particular channel. We know what pulse code modulation is about. So in pulse code modulation we will be having an analog signal. So this analog signal will be sampled by a large frequency at different instants, and then each samples are quantized and each quantized levels are encoded with the help of binary digits. So that results in PCM signal. Of course, this is PCM signal is a digital signal. So that's why we are saying pulse code modulation signaling is a digital signaling method in which we make use of DC control signal, and what we do is this DC control signal will be sampled and then transmitted. And we know that this DC control signals are associated with proper operation of this audio frequency baseband circuits, of course in each direction, so either in this direction or in the opposite direction. So the speech circuit or the baseband circuit should operate in a proper way, and that will be taken care with the help of control signals or signaling signals. So in this PCM signaling, what we do is we will convert this DC control signal into a digital signal. So that is what, with the help of sampling, and then it is transmitted over the medium. So once we convert this control signal into a binary signal, so whatever we obtain will be stored inside a PCM frame. As defined, control signal samples are transmitted within the PCM frame of PCM channels. So we discussed before how PCM channels are going to form a PCM highway when we discussed space switch as well as time switch. There also we discussed how a PCM frame would look like. So this is how a PCM frame would look like. So we know there exists so many number of channels. From each channel we are dealing with one particular time slot. So if we are having, so generally in our PCM signaling, so we make use of 32 different channels. So from each and every 32 different channels, so we will be having 32 different time slots. So as shown in this figure, so this is what a PCM frame is, which includes total of 32 different time slots named as 0, 1, 2 like that up to 31. So in total 32 different time slots are used. Out of these 32 different time slots, so let us consider one particular time slot. So this basically, this time slots stores 8-bit binary data or digital data, or I can say digits. So 8 digits are saved inside a particular time slots. So each digits are involved in defining speech magnitude. We know the DC signals are sampled, whether the DC signal or whether it is a speech signal. So we know speech signals are also transmitted over the speech band or speech circuit. Similarly, the control signals are also transmitted over the speech circuit or a particular separate circuits or dedicated circuits. So basically whatever the control circuits or whatever the control signals we are transmitting from one end or from one exchange to the another exchange, so that will be taken care with the help of time slot 16. So this time slot 16 is basically look into signaling part of our data transmission. So of course we are having one more time slot, that is time slot 0. This is used for frame alignment. How these frames, of course how this PCM frame should be aligned into our channel. So all those things will be taken care with the help of this frame alignment. So in each time slot we are going to store 8-bit digital data. Please note. And excluding these two remaining, so from time slot 1 to time slot 15, so total we are having 15 speech channels, so where these time slots are storing speech signals. Similarly from time slot 17 to time slot 31, so total we will have 15 different speech channels. So all those are involved in transmitting speech samples. So whatever the analog signal was there at the transmitter end, so that analog signal is converted into digital with the help of pulse code modulation and then transmitted via this different channels. We know PCM channels, so from each and every channel we will have corresponding time slots. So total this particular PCM frame supports 15 plus 15, 30 different speech channels. 30 different speech channels are supported by this PCM frame. So as I said, one speech sample was taken here. So generally all 8 bits are used for representing speech magnitude. Sometimes if required, if we want to mention whether the polarity also, sometimes some signal may go positive as well as some signal may go negative. In such cases we may make use of polarity bit, or the MSB will be considered as polarity bit. If it is 0, whatever the signal amplitude we are mentioning will be considered as positive with respect to particular reference value. So it need not to be a 0 amplitude level. We may consider particular reference value. With respect to that reference value, the signal may go positive as well as negative. So from here to here maximum, so we have to differentiate signal amplitudes. So that will be taken care if it is going positive as well as negative. In such case bits will be D1 bit will be used for representing polarity. Similarly if it is 1, then whatever the magnitude we are dealing with, that defines a negative going amplitude. So that is how all speech signal information will be stored inside a PCM frame. So the total duration for a particular PCM frame includes 125 microseconds. So that's why we call it as PCM frame time duration. So that is 125 microsecond. So you should ask why 125 microsecond is exactly used by a particular PCM frame. So this is used because we are making use of a sampling frequency of 8 kilohertz. We know speech signal can go vary from 300 hertz to 3.4 kilohertz. So by including outband signaling with the help of outband signal or with the insertion of control signals, so the maximum level gone up to 4 kilohertz. So if I say the speech signal is going from 0 to, let us say 0 to 4 kilohertz, then the maximum frequency content of that speech signal is going to become 4 kilohertz. So if 4 kilohertz is the maximum frequency content, then the sampling frequency, the minimum sampling frequency or the Nyquist sampling frequency that I have to select is going to be twice that of the maximum frequency content of my speech signal. So that is going to be 8 kilohertz. That's why we are using a sampling frequency of 8 kilohertz. 1 by 8 kilohertz gives the time period or sampling interval of each sample, and that was found to be 125 microseconds. So that's why we are, so please note that within 125 microsecond, in order to send a particular sample, we require just about 5 microsecond. So what we did was, so instead of sending only one sample signal within this 125 microsecond, so what we did was we make use of other signal samples and we passed through the channel. So that is what space switch is about. So we have already discussed how space switch and time switch operates. So we know how frames are formed, PCM frames are formed to transfer multiplex data or to transfer different signals over a particular channel. Basically, we need to discuss about this time slot 16. So this time slot 16 is also having 8 different bits stored inside this, and all those 8 bits are involved in providing controlling for the transfer of these speech signals. So all 30 different speech signals will be transferred with the help of these information that is stored inside our 16th time slot. That's why this time slot is sometimes called as signaling time slot. So as shown in figure 8, this is what figure 8 is, that is PCM signaling frame. So with respect to this figure 8, the PCM frame of 30 channel systems is divided into 32 time slots. We know that 30 channels are used in our PCM frame for sending signals, that is speech signals. Of course, all 32 time slots are of 8 bits, and with this the total bit rate is going to become 8 kilohertz, which is the sampling frequency, into 8 bits are used into 32 different time slots. So total bit rate of a particular PCM frame will be equal to 2.048, approximately 2 megabits per second. So this is what the data rate or bit rate of PCM frame that is transferred over a particular channel. As I said, time slot 1 to 15 and 17 to 31 are used for transferring speech signals. Similar, time slot 0 for frame alignment and time slot 16 for signaling. So the 8 bits of channel 16, so whatever the 8 bits that are stored inside our channel 16, that is, if I am speaking channel 16, it is understood time slot 16, are shared between all 30 different channels by a process of multiframing. So this is very important. So inside PCM signaling we make use of multiframing. So multiframing is used in order to share whatever the data that is available in time slot 16 by all 30 different speech channels or all 30 different speech time slots, and that process is known as multiframing. So let us discuss how multiframing will be considered. So as shown in figure 8, 16 successive appearances of channel 16 form a multiframe of 8 bits. So in order to control the data transfer with respect to these speech channels, we are going to form 17 different frames, and all 17 different frames make use of this time slot data, that is 16. So that is basically used for signaling. So out of them, first frame, that is frame 0, is generally used for multi-frame alignment. So of course it is also 8-bit information that is stored inside this frame 0. All 8 bits are utilized here. So this frame alignment is required in order to align these frames one after the other in the proper manner. So that's why we make use of frame 0. So excluding this frame 0, total we are having 16 different frames. All frames are associated with different channels data transfer with the help of this control signal or control signaling information. So let us consider frame 1. In frame 1, this frame 1 supports whatever the data that is stored in channel 1 as well as whatever the data that is stored in channel 17. So with respect to this channel 17, let us say total 1 to 15 plus 15, total 30 different speech channels are there. Out of them, first channel will be supported by frame 1, as well as the same frame also supports channel 16 also. 4 bits of this 8 bit will be used for controlling of data transfer, that is speech signal transfer via channel 1. Similarly, remaining 4 bits will be utilized for control of data transfer via channel 16. So in the same way, channel 16, if I am speaking channel number 16 used for speech, if I consider here, it will be 17th, like that. Similarly, frame 2 will be able to control channel 2 as well as channel 17. In the same way, last frame 16 will be controlling channel 15 as well as channel 30. If I exclude channel 0, or sorry, frame 0, so in total we will be having 16 different frames that this time slot or channel 16 is supporting. So the total time duration of this multi-frame, this is what multi-framing is. So that will be equal to 16 into 125 microsecond. Each frame will be about 125 microsecond. So 16 into 125 microsecond is going to become 2 millisecond. So the total time duration of the multi-frame that is used for PCM signaling will be about 2 millisecond, as we have shown here. So the total time duration is going to be 2 millisecond, and that is about 125 microsecond into 16. So thus this figure 18 shows the use of multi-frame for signaling in 30 channel PCM system. So right now we are using 30 different speech channels, that's why we call it as 30 channel PCM system. So as defined, the first frame, that is frame 0, will be used for multi-frame alignment. So that's why first frame contains a multi-frame signal alignment signal, and each of subsequent 15 time slots contains 4 bits for each of 2 channels. So 4 bits are used for each channels. We know whatever the speech circuit we have in our system, that is switching system, so those speech circuit are going to operate in both directions. Of course, when a particular speech circuit is controlled by a single signaling channel, let us say single signaling channel means, so whatever we have discussed, this is a single signaling channel. So associated with time slot 16, we will be having a single signaling channel, and that single signaling channel will be controlling all 30 different speech signals for a particular speech circuit. And this single signaling channel will be operating at 2 kilobits per second. So if I make use of single signaling channel, then the data rate inside the single signaling channel will be about 2 kilobits per second in order to support speech circuit in both the directions for data transfer or speech signal transfer. Whereas if I make use of 4 independent signaling channels, instead of using single signaling channel, if I make use of 4 independent signaling channels, then we require about, or the data rate of each and every 4 different independent signaling channel will be about 500 bits per second. So this is what different data rates associated with what the number of signaling channels are used in order to control a particular speech circuit in both the directions. So please note, with the help of PCM signaling, we are able to provide large number of signals. We are able to multiplex large number of speech signals, and of course these signals are exchanged between 2 different exchanges. So but that was not the case when we discussed earlier, that is DC signaling methods. So please note, in DC signaling methods, whatever we have discussed in section 3, there we were able to support less number of signals compared to TDM carrier signaling systems. So TDM carrier signaling system is nothing but PCM signaling system, which is a digital signaling system. So digital signal system supports large number of signals over analog signaling system, where DC signaling methods that we have discussed earlier. Thank you.